The question here in this video is, does the GB4000 do AM? Well, let's see. We'll turn it on. Start. We're gonna select RF mode. So we're in RF mode. That means that the carrier is turned on. So we're going to be using a carrier. We want to select sine or square wave. There's square wave. There's sine wave. We're selecting sine wave. We want to select our modulation frequency. Enter. We're going to select 14,000 hertz. And then run. So the GB4000 is now running a 14,000 hertz sine wave modulation on a 3.1 megahertz carrier. Let's see what that looks like on the oscilloscope. Okay, we'll just adjust our sync there. So it looks like a pulsed square envelope of carrier. The carrier is pulsing on and off in a square fashion. That is not textbook AM. It's more like, you know, the carrier is turning on and off with a null in between. But this does have AM characteristics, because if we look at it on the spectrum analyzer, what we can see is we have our fundamental 3.1 megahertz carrier. That means the cursor is on the peak of the fundamental frequency, and the fundamental frequency is reading out here at 3.1 megahertz. So if we can see that alongside of this fundamental is a bunch of sidebands, and if we scan our cursor over to the first sideband, we can see that the first sideband is 3.1 megahertz plus 14,000 hertz. You can get a better accuracy by reading the second sideband. So let's just scan our cursor over to that second sideband, and there is exactly 3.1 megahertz plus 14,000 hertz times 2, which gives 3.128 megahertz. And you can see the cursor is exactly on the peak of the second sideband. So that makes sense. The idea here in this video is that the GB4000 unit doesn't put out a textbook AM wave, but it is putting out an amplitude modulation signal complete with sidebands. And that signal actually looks like the carrier is being pulsed on and off at 14,000 hertz. Now if we spread out this way, we can actually look at the carrier wave, which there's the carrier. It looks kind of pointy, but that's your 3.1 megahertz there. And if we broaden out our time base, you can see the modulation appear. So there's the modulation, and there's the carrier. It seems that the carrier has a slight ringing as it crosses 0 point.